Okay, now we'll continue with Cauchy's integral formula for derivatives. Okay, this is the general formula. Integral over c f of z by z minus a whole raised to n dz is equal to 2 pi I by n minus 1 factorial dn minus 1 by dz n minus 1 f of z at the point z is equal to a, where a is equal to z is equal to a lies inside c. So now when n is replaced by 2, we will be getting this f of integral f of z by z minus a square. That is instead of n, if you take 2, here also 2 pi I by 2 minus 1 is 1. So 1 factorial. So we write 2 pi I, then d by dz. Why do we get d by dz? Because n is 2. When n is 2, 2 minus 1, 1. Here also when n is 2, 2 minus 1, 1. So d by dz f of z at z is equal to a. So first you can learn this general formula, and from this general formula we can take for different values of n. So here for example we have taken for n is equal to 2. So now let us go to the problem session. We'll learn some example problems. That is first example is evaluate using Cauchy integral. That is integral over c e power 2z by z plus 1 whole power 4 dz, where c is modulus of z is equal to 2. So how to differentiate between Cauchy integral formula for derivative and Cauchy integral formula? You should look into the denominator, and if there is some power for the denominator term, then we have to apply Cauchy integral formula for derivative. So that's what here you say f of z by z minus a whole raised to n. So in the previous session we learned Cauchy formula is f of z by z minus a. We apply the ordinary formula. When you have some power, that is f of z by z minus a power n is here, right? So when you have power, you have to apply this formula. So here what about the power? N is 4. So when n is 4, this formula will turn to 2 pi I 4 minus 1, right? 4 minus 1 means 3 factorial. D here also 4 minus 1, 4 minus 1. So d cube by dz cube f of z at z is equal to a. So that's what we are going to, how we are going to continue with. So now before that we have to verify whether z lie inside or outside. Now we take the denominator z plus 1 whole power 4 is 0. Z is equal to minus 1, right? So equating denominator to 0, we get this. From this we can write z plus 1 equal to 0, and from this we can write z is equal to minus 1. And also now we will verify whether this lies inside or outside C. Mod z is equal to 2 means we get, what about this? Radius is 2, right? 2, this point is minus 2. Since radius is 2, we can draw the circle, and we can take the endpoints as 2 and minus 2. And what about this particular point, this minus 1? Minus 1 comes here, right? This is 0. This is the circle mod z equal to 2. So since minus 1 lies inside, we can follow the Cauchy formula for derivative. So we say minus 1 lies inside C, or we can follow the other method also without drawing the curve. Z is equal to minus 1. So you take the given circle mod z equal to 2. You substitute, instead of z you substitute minus 1. Mod z equal to modulus of minus 1 is equal to modulus of minus 1. We take the absolute value 1. 1 is less than this radius. So in the previous example we learned this. You can substitute z value in the circle, and after finding the solution, if that particular value is less than the radius is 2, less than the radius, then the given z value lies inside the curve C. So here also z is equal to minus 1, modulus z is equal to 2 means after substituting z as minus 1, we get this particular value lies inside C. Okay. So now we take this and we apply the formula. N is equal to 4. So we apply this formula. When n is 4, just now I explained 4 minus 1, 4 minus 1, 4 minus 1. So all this n minus 1 will become 3. 2 pi I by 3 factorial. So we get this 2 pi I by 3 factorial d cube by dz cube. F of z. What is f of z? F of z is the numerator. So we know in Cauchy integral formula, numerator is the f of z value. F of z is e raised to 2z. So instead of f of z, applying that formula. So what is the formula here? You can take down this formula first. Okay, take down this formula, then take n is equal to 3, substitute it here. F of z is the numerator, that is e power 2z. Now we have to differentiate e power 2z 3 times. Okay, let me explain that. If you differentiate it 3 times, okay, because cube is here, what will be the first derivative of this? E power 2z derivative is e power 2z. Then you have to differentiate the power 2 into 1, right? So you get 2 e power 2z, that is you get the first derivative. So cube will become square now because we have differentiated one time, cube will become square. So if you differentiate it second time, again e power 2z, it is e power 2z only. So into 2 will be, already you have a 2, e power 2z is e power 2z into 2. So you get 4 e raised to 2z is the second derivative. So you get 4 e power 2z, and this square will become 1 because derivative is reduced by, we have differentiated it one more time, so d by dz. Now we will go to the next derivative. So this derivative of this is 4 is constant, and e power 2z again e power 2z into 2. So we get 8 e power 2z. So differentiation of this is 8 e power 2z. So we can apply it here. D cube by dz cube e power 2z is 8 e power 2z. Also we want it at z is equal to minus 1. What's our formula at the point? F of z at z is equal to a. Okay, f of z at z equal to a. What is a value? Z is equal to a. A is nothing but this minus 1. Denominator, from denominator we have to take the a value. A is the z value when you equate the denominator to 0. So a is minus 1. So at the point minus 1. So let us find this value at the point z is equal to minus 1. So at the point z is equal to minus 1 means 8 e raised to 2 into z is, instead of this z you substitute minus 1. That is 8 e power minus 2 is the answer. So we can substitute that in this, instead of d cube, what is that? D cube by dz cube e power 2z is 8 e raised to minus 2. 8 e raised to minus 2. So we get what is that value? 8 e power minus 2. We'll substitute it here. Now 2 pi I by 3 factorial is 6. So 2 pi I by 6, 8 e raised to minus 2. Now here this 2 and 6 you can eliminate. So pi I by 3, pi I by 3, 8 is there, e power minus 2. So 8 by 3, eliminating this 8 by 3, pi I e power minus 3 is the integral value of the given question. Okay, we'll continue with the next question. Evaluate integral sine power 6 z by z minus pi by 6 whole power 3 dz by Cauchy's integral formula, where C is the circle, modulus z is equal to 1. So here solution, first let us find the z value and we verify whether that value lies inside the given circle or not. So the first thing you have to do is you equate the denominator to 0. Okay, always you equate the denominator. So z minus pi by 6 whole cube is 0. Z is equal to pi by 6. Now what about the given circle? Given circle mod z equal to 1. So we take modulus z is equal to 1, and let us just substitute instead of z we substitute pi by 6. Okay, so modulus z is modulus, what is z? Z is pi by 6. So modulus pi by 6, which is equal to 0.5233, which is less than 1. 0.5 is less than 1. So we say this particular point lies inside C. So here you take the pi value as 22 by 7. Okay, we take 22 by 7 by 6, you get this, and we say it lies inside C. So by Cauchy integral formula, whenever it lies inside C, we can apply Cauchy integral formula. If it lies outside C, we know its value is 0, right? If it lies outside C, value is 0. Since it lies inside C, we can apply Cauchy integral formula for derivative. Why do we apply Cauchy integral formula for derivative? Because in the question denominator you have the power 3. So whenever you have a power for the denominator term, we apply Cauchy integral formula for derivative. And the formula here is 2 pi I by n minus 1 factorial. What is n here? N is 3. And f of z is the numerator sine power 6. Let us apply this. Okay, this is the formula. So when n is 3, so here when n is 3, 2 pi I by, we get 2 pi I by, Okay, 2 pi I by 3 minus 1 factorial d. Since n is 3, we get square. 3 minus 1, 3 minus 1 square. D square by dz square. F of z at z is equal to a. What is f of z? F of z is the power, that is sine power 6. And a value, we got the a value, that is pi by 6. Using that formula, we get this, okay? We get this at the point z is equal to pi by 6. So now here this 2 and 2 will be eliminated. We get pi I d square by dz square, d square by dz square, then sine power 6z at the point z equal to pi by 6. So now let us differentiate this sine power 6z. So when you differentiate this first time, we can apply the formula x raised to n form. So first we will be applying this equation, okay, because power is 6. N is, what about the n value here? N is 6. So we get 6 sine 5 z, because n x raised to n minus 1. X is sine z. So 6 sine power 5 z. N minus 1 is 5. So also what the next thing, we have to differentiate sine z also. In differentiation of sine z is cos z. So this is the first derivative. Actually we have to differentiate 2 times, right? We have to differentiate 2 times. So this is second derivative 2 times. This is the first derivative, right? Sine power 6, we have differentiated this first time to get this. So let us differentiate one more time. That's why I have taken d by dz here. Second time means what? While differentiating next time, I have taken this 6 outside, and we have to follow the product rule, UV rule, okay, UV rule. That is u into, formula is u into v dash plus v into u dash. So u is sine power 5 z, and derivative of v, cos z is minus sine z, plus v into cos z into u dash. U dash means differentiation of sine power 5 z. What is u dash? 5 sine power 4 z. 5 sine power 4 z, using this formula, okay? 5 sine power 4 z. Also we should do one more thing. We have to differentiate sine z also. After applying this formula, we have to apply the formula for sine z. Derivative of sine z is cos z. So we get this. Now 6 into minus sine 5, you have one more sine z. So 6 z, sine power 6 z. So here when you come to this, plus 5 sine power 4 z, cos z into cos z, we get cos square z, okay, cos square z. So you get this step, okay, and the differentiation part I have substituted here. You see 2 pi I by 2. So pi I will be here. After we take this, you can take this 6 outside. That's what we did here, right? Taking this 6 outside, we get this. So this much term I substituted there. 6 into, we get 6 pi I into minus sine power 6 z plus 5 cos square z sine power 4 z. Z is equal to pi by 6. So the thing is, just I have substituted this differentiation which we have done in the previous page. I have substituted here. So now you get like this. Now at the point z equal to pi by 6, okay, instead of z we have to take pi by 6. So because z value is, so we know z equal to pi by 6 is the point here. So instead of z we substitute this. Now we know z power pi by 6 value, sine pi by 6, cos pi by 6 value, let us substitute it here. So sine, we have to find, we should know the value of sine pi by 6, okay. Sine pi by 6 is sine 190 by 6, that is sine 30 degree. What is sine 30 degree? Sine 30 is 1 by 6. So we need sine pi by 6 whole power 6, okay. We need power 6. So taking power 6, sine 30 is 1 by 2. Taking to the power 6, we get 1 by 64. Cos 30 is root 3 by 2. So we need square. Cos square pi by 6 means root 3 by 2 the whole square. Root 3 square is 3. 2 square is 4. So we get 3 by 4. So let us substitute this value. Also sine power 4 5 by 6 is 1 by 16. So substituting all this value, we get the solution here. So this is the solution. After substituting the value, 21 pi I by 16 is the answer. Okay, this gives the integral value.